Okay, guys, we're gonna do lesson 9.1 geometric mean, and the geometric mean, you guys, works for right triangles, and it's one of those magical ones in which you can have to the end root of a triangle, meaning that you can make a lot of triangles from one triangle, infinite amount of triangles, as long as you stick to the rule of doing something forever. For example, just if I was to have like a right triangle here, something like that, and I apologize if it doesn't come really, really straight, and this was 90 degrees. Well, guess what? I could come in here and create another right triangle, from here. If I make this one right somewhere in here, if this was to be 90 degrees, see? Then I have another triangle. Well, guess what? This little line right there, this line right there is the geometric mean, okay? And by the same token, I can come over here and I could do this. That's another geometric mean. And then, of course, I can find the lengths, this length, that length. I could also find that length, but this will be a perfect, if this was to be, but it's got to be 90 degrees, guys. Mine is not so good. So let's say this is 90 degrees. Then again, I can just go back and forth and just create infinite amounts of right triangles within a right triangle. And that's what the geometric means and is supposed to do. Okay, so let me just erase that just a little bit. And that's in a nutshell what this means right here. Okay, the geometric mean is a set of numbers. It's an end root where n is the number of elements in the set number. Okay, so you can tell right there, guys, that you can find it by making it proportional, because it will be similar, so it can be proportionate to it, and it will be the square root of a and b, or the two values involved. Now, so let me show you what that looks like. If I was to do this just a little bit, let me see if I can enlarge that just a little bit. Okay. Okay. So the geometric mean, or the altitude theorem. So we have like a theorem on an idea of how to do this. And see, you have the right triangle right there, and you can just spread right there to another right triangle. And that way, we'll be able to know, if we know h, we find out h. If we know this length and that length, we can find h. If we know this length, we can also find h and y. But for the purpose of finding the geometric mean, this length, this altitude right there, which is the geometric mean for this specific figure, we have to multiply x and y together and then take the square root of that. Of course, taking into account a squared plus b squared equals c squared, and that's how we come to put this into square right there. So with that in mind, guys, let me go to example one. Just see, just keep that in mind for right now. Of course, the geometric theorem also says that if we were to know something like a b right there, then we have to do the square root of x and then c, and c will be this whole length right there. Okay, so if you're across that, you need to take the first one times this whole length, x plus y, basically, and that will be c right there. Okay, but we'll practice a little bit on that one, guys. Okay, so let's try this one. If they want us to find the geometric mean between 5 and 45. So as you can see right away, guys, we come in here, and all we have to do is just multiply 5 times 45 right there. And of course, if you don't want to use a calculator, you can always just do this and put it on the side, and you multiply that. You're going to get 25, and there is 2. I think it will be 225. Is that correct? I believe it is. So then, of course, we put 225 right there, and it's the square root of that, and we still have an x. Okay. So what is the square root of 225? That's the question, and you will use just like a simple calculator. And I really suggest. Let me see if I can go back to my dashboard here. I'm going to lower this, and you can get your Desmos calculator, which I think is the best. Let me see if I can. Let me see if I want to erase that, but since I cannot do that, guys, I'm gonna go back to this one. I'm going to go Yeah, just get my calculator. Yes, it's basic calculator. We'll do this to find the square roots, guys. And I go, okay, I got the square root of 225. I believe it's going to be, oh, it's backwards. Okay, so I got to do, let me erase that. I got to do 225, and then I need to take the square root. Okay, and that will be 15. Sorry about that. Okay, so this would be 15 right there. Okay, so if I come in there and I can put 15. So if we had like a triangle right there, guys, the altitude will be 15. And that's basically what it is. Okay. Alrighty, it's really, really simple, guys. So if I was to kind of have like an image of this, guys, I will say, well, I have a right triangle, something like this, and then I get something like that. And I'm just kind of making a hypothesis. That's what I believe that this is. So I'm going to go here and say, well, this is the, and although it's going to look big right there, guys, and I will say this is 5 and this is 45. What is the geometric mean, for, and let's say this one was X. Okay, that's really what the problem was saying. And of course, we found out it was 15. So this height right there is 15. And that's what I meant. Okay, very simple. Okay, let's go to example 2.